Yeah.
I hope that all
Thank you.
participants are eagerly waiting for the first session. Sharjad, AJ, have you joined? Sharjad?
Yes.
Yeah, okay. You
Yeah, let's continue.
please enable co-host access. Please. Sharjad, are you able to share the screen? You can turn on your video also.
Yeah, I just share my screen. Could you please confirm whether it is?
Yeah. First, I'll just introduce. You can, anyway, your screen is visible. Yeah.
Yeah, okay.
I'll introduce Sharjad. Sharjad is from COMSOL. Sharjad is an experienced and driven aeronautical engineer, currently serving as an application engineer at COMSOL. With a master's degree in propulsion engineering from College of Engineering, Trivandrum, he brings a strong background in aerodynamics, computational fluid dynamics, heat transfer, and propulsion. Sharjad has over 13 years of expertise as an application engineer, CFD, and has a proven track record of fostering collaborations with leading academic institutions and defense labs, enhancing research and development efforts in this field. Welcome, Sharjad, for your talk.
Okay. Thank you, ma'am. So, first of all, thanks to the entire IIIT Kottayam team for inviting us to participate in this particular FTP program on AI and emerging technologies for sustainable energy and the climate adaptations. So, so today, primarily, my presentation will be focusing on the multi-physics modeling of and optimizations of renewable energy systems, and what all are the machine learning techniques which COMSOL offers. So that will be the primary area of today's sessions, what I am going to deliver right now. And at the end of the presentations, I'll just open few models in COMSOL multi-physics, and I'll just showcase something related with the energy side, like a solar cell and one heat exchanger problem. So that is actually the entire plan of delivery for this particular session. So without wasting the time, I'll just quickly move to the introduction. So as the title says, COMSOL multiphysics, and when we connecting with the agenda of today's session, this particular FDP program, that is a sustainable energy. So there will be a kind of question in all the researchers' mind when we are developing a kind of a product, that what is the necessity of doing a multiphysics simulation for the product development. So our ultimate objective was for developing a product or any kind of a device is to attain the maximum efficiency or attain the optimum efficiency. So the optimum efficiency in the sense reducing all sort of losses and make it as a sustainable one. So on those perspective, multiphysics simulations will be really important. If we take an example of the transformer, which is shown in this particular figure itself, so the primary physics or the dominating physics in this particular example is electromagnetics. That is, specifically we can call it as low frequency electromagnetics. So if you are designing a device without considering any other aspects or any other physics, only you are looking into the electromagnetics part, then there will be a lot of losses. So that's eventually will leads to an unsustainable way of usage. Okay, there will be a lot of losses. So such kind of issues will happen. So for that, we need to understand what all are the losses incorporated in that particular device, like transformer. So while the transformer is running for a long period of time, the primary losses will be in terms of heat. So we need to understand the heat generation. So for that, actually, on top of low frequency electromagnetics, the second physics will comes into the picture is heat transfer. So we will understand about the heat generation. So once we identifying that, after the heat transfer simulations, we understanding that, okay, the temperature is going beyond the permissible limit of that particular material. So that is also sometimes will leads to some sort of losses. So for that to understand, we will do the cooling analysis, or we use some cooling mechanisms, so that we need to use CFD. So now when we while considering these three aspects, you can understand that low frequency electromagnetics, heat transfer, and CFD, all these three physics are comes together in a single system, or they are mutually interacting in a single systems, like the transformer which I have explained right now. So this kind of systems or phenomenons are we collectively calling it as multi-physics phenomenon. That is, if we collectively saying, if a system or a phenomenon consisting of multiple mutually interacting physics are involving, such kind of devices or phenomena, we calling it as multi-physics phenomenon. And when it comes to the sustainable development of a product, or when it comes to the sustainable uh, R&D process of any kind of a device or the product development, we have to do a multi-physics simulations, and we need to understand what all are the losses that can occur in the future, and we need to modify our designs, or we need to develop our device by reducing such kind of a wastage in terms of energy and in terms of materials. So on that point, all simulations or R&D process will be useful in R&D process for reducing such kind of losses, and we can make it as a sustainable product. That is a one aspect why simulations will be, or how simulations will be connected to sustainable energy or sustainable developments. Next thing will be, if you are going with the, or in generally we do have two major R&D processes. First one will be like majority we will go with experiments. Okay, so experiments are, first thing is time consuming, second thing will be the cost, because there will a lot of cost involving in that, and it requires a lot of effort. So if you are doing an experiment, definitely there will be a lot of energy consumptions as well, and you are only focusing on your R&D process in the experiment perspective, there will be a lot of usage of energies in terms of electricity, in terms of thermal. Okay, all those consumptions will be there for doing. If you have 100 set of iterations you need to do, it's used a lot. So but instead of that, instead of doing all those 100 iterations as an experiment, you can use the aid of simulations, where you can find out which is the optimum 2 or 3 iterations or 2 or 3 combinations. Then you only want to do the experiments of all those 3 combinations. Then you can identify which is the best one, and you can compare those results with the simulation. So on that perspective as well, the energy consumptions we can reduce during the R&D processes if you are adopting multi-physics simulations, and also the material usage, cost, everything will be cut down if you are using simulation technology. That too from a tool like COMSOL multi-physics, because we do have dedicated interfaces for solving all sort of multi-physics simulations. So, as the title said, COMSOL Multiphysics, we are well capable or well versed the simulation platform, which offers the various multiphysics simulations. So, for an example, electromagnetic heating, the heating because of the electromagnetic effects, or it could be the fluid structure interactions. Because of the fluid flow, there will be a lot of stress formations in the structures. Okay, so such kind of interfaces you can do. So all sort of multi-physics simulations, you can directly solve it using COMSOL multiphysics, where you don't want to use multiple GUIs. All those simulations, you can run it in a single GUI, and you can perform your multiphysics simulation. So the next question will comes into the user's mind. Okay, yes, COMSOL is well versed for multiphysics. Then what about for the single physics? So single physics simulations can also be done in COMSOL, like CFD alone, structures alone, electromagnetics alone. So all those cases, we can use single physics as well. And why we recommend single physics for certain cases is, we usually start developing any kind of a product with certain set of analytical data, or as well as few data from our theoretical knowledge. So for doing a multi-physics simulations, it's required a lot of inputs from the user end. So if you're starting a problem with a multi-physics approach, then there will be a lot of data we need to give it, but sometimes we might not have that much data available. Then it will lead to some sort of unwanted results, or the results will not be good enough that what we expecting. So that we usually start with single physics. Then after that, we will gradually add physics one by one based on our own requirement for developing any kind of a multi-physics models. Then we will do the multiphysics simulation. So COMSOL multiphysics is a well-versed simulation environment for both single physics and as well as the multiphysics simulations. So that is all about why multiphysics simulations are important and how the simulations are being connected with the sustainable R&D processes. Hello? Yeah. So now I'll just give a brief idea about what all are the offerings from COMSOL multiphysics, or what all are the physics COMSOL handles. So the first physics will be CFD, the fluid dynamics, where you can solve all the problems related with the fluid flow. It can be like a single phase flow, like laminar flow and turbulent flow, or if you want to solve a multi-phase flow where two different type of fluids like gas and liquids are in a single system, or two immersible liquids system, all such kind of a problems you can solve it using these fluid flow or the CFD products that are available in COMSOL. Next physics will be the electromagnetics. So when it comes to electromagnetics, we usually, or we broadly classified electromagnetics into two subcategories. First one is a low frequency electromagnetics, and another will be the high frequency electromagnetics. So the low frequency electromagnetics is something related with the electric machine designs like electric motors, generators, inductors. So such kind of applications we can handle through the low frequency electromagnetics products. Then next will be high frequency. So one of the product is in the high frequency is RF module. So that is specifically for the high frequency applications like antenna design, EMI/MC analysis of PCBs, all such kind of a high frequency simulations you can run it using such modules. On top of that, we do have modules for the semiconductor related applications, like especially the semiconductor devices like MOSFETs, transducers, then all those kind of semiconductor products or semiconductor devices we can solve from the electromagnetics perspective. And also we are capable of solving the plasma problems directly. We do have dedicated interfaces for the plasma related applications, and also the electric discharge simulations we can use the electromagnetics module. Then next one will be heat transfer. So when it comes to heat transfer, we all know that we do have three modes of heat transfer, basically conduction, convection, and radiation. All three modes of heat transfer can be simulated using COMSOL multiphysics, either in a standalone way or as a combination of all three, or either two of them. Okay, all sort of simulations we can run it using COMSOL multiphysics in terms of heat transfer. Next is the structural mechanics, or the structural mechanics module, where we can simulate both linear and nonlinear problems in terms of geometry and as well as the material nonlinearity. And also there are like modules for the composites, rotor dynamics, all those kind of a structural related problems we can solve using the structural mechanics module. The next physics is the chemical engineering module. So this is specifically for the chemical and as well as the electrochemical related applications, battery, fuel cell, all such kind of simulations we can run it using the electrochemistry or chemical related interfaces. The other physics is acoustics. That is something related with sound. So basically, there are two main reasons for the sound generation. So first one will be the vibration because of any structural component, and the other one will be the sound or the noise generation because of the fluid flow. So basically, both the cases we can solve, like either vibroacoustics or the aeroacoustics. Both those simulations we can run it using COMSOL multiphysics. So these six are the different physics interfaces or the physics-based products that are available in COMSOL multiphysics. On top of that, we are offering an additional feature called equation-based modeling. So because as we all know, research is not just limited with all of the built-in features available. Sometimes we need to develop our own physics sometimes, okay, based on our own equations. For that, you can use the equation-based modeling approach, by using equation-based modeling approach, you can build your own physics interfaces on top of the physics interfaces which is available within console right now. If you want, you can build your own interface by using certain set of equations, like it can be PD or ODE. All those kind of equations you can add, and you can build your own interface. That is a one approach, using equation-based modeling. The another one is adding additional equations to the existing physics interfaces. For an example, if I want to add an additional source term in one of the laminar flow problem, okay, so such kind of additional terms also we can add it through the equation-based modeling. And how this equation-based modeling differs from some other tools is, basically for other tools, this equation-based or the customization is more on the coded front, where we need to write code. But here, actually, like we have a GUI, like equation-based modeling or the general mathematics interface is a GUI. By using GUI, actually, you can add the new equations to the system, or you can build an interface itself using this GUI. But those who are interested in code, there are method options where you can build your own code using JavaScript, and it will be more on the coded front. So both feasibilities available in COMSOL, that you can add additional equations or build your own physics interfaces through equation-based modeling with GUI approach, or as well as the through a programming or a coding approach. So that is about the equation-based modeling. The next one will be the optimization. So optimization is really important when it comes to a sustainable development of any kind of a devices, because initially we usually start the designing process of any product with very basic understanding from our physics knowledge, and as well as the several analytical data. But that design might not be the best one. There will be a provision to optimize in terms of the shape when it comes to the fluid flow related problems or any kind of structural problems. Shape optimizations will be really important, where we can reduce the shape of that, or we can optimize the shape of that particular devices to get the better performance, so the losses will be less. When we take an example of external aerodynamics of a car, okay, where there are a lot of places where drag is too high, that drag is actually leading to the more consumption of fuels. So by using this shape optimization techniques that are available, you can optimize the shape in such a way, or in an objective, that to reduce the drag. So you can reduce the drag, and you can increase the aerodynamic performance of the car, and that will eventually increase the fuel efficiency of that particular car itself. That is one way of optimization called shape optimization. Another will be primarily on the topology optimization. It is mostly for the structures, where the objective is the material reduction. So there are few over designed parts will be there in if any kind of devices. Those kind of over designed parts we can optimize using the topology optimization technique. By using topology optimization technique, you can optimize your design or the part in such a way that with a less material, without adhering the capability or without adhering the physics. So such kind of optimizations you can done it using the topology optimization technique. By using such kind of a techniques, actually you can cut down the material. So of course it will again cut down the cost of your product. So such kind of optimizations you can do using COMSOL multiphysics optimization interface, and these optimization techniques will be well versed with all the physics tools which COMSOL offers. It can be CFD, structures, electromagnetics, heat transfer, all those physics you can use this kind of optimization techniques. On top of that, we are providing certain live-link features with some other tools that I'll give an idea in the later slides. So that is all about the various physics which we handle using COMSOL multiphysics. On top of this physics-based products, COMSOL offers the capabilities for the building simulation apps, and based on the simulation app, you can build the digital twin of your model. Okay, so simulation app is nothing but it is similar to an applications which we are usually use in our phone. Instead of doing the entire simulations to get a very fast simulation, we will select few necessary input, and we will again select few necessary outputs. Based on that, we will build an app, and this app can be run even without a COMSOL license. So I'll just show you the how an app looks like during the demo part. So this is how an app looks like. So app is nothing but a simple application. It's not a complete simulation where you want to provide geometry, meshing, no such operations are not required. Initially, we need to do all these things. We need to build a model. Then after that, it can be converted into an application where only limited inputs we need to give, and we will get the desired outputs. So such kind of feasibility is there. I'll explain those things in the demo part. But just understand that by using such kind of an app, actually we can build digital twins using COMSOL multiphysics on top of those kind of a physics-based simulations. So as we all know, digital twin is something like a connection between the virtual space and as well as the real space. There's supposed to be data transfer between these two spaces. In COMSOL digital twin models, how we implement this kind of a connectivity we have been getting through several web services. And here you can see the virtual space has been built by a simulation COMSOL simulation app, and we connecting through the real space through this particular web services. Okay, so it is actually like a to and fro bi-directional connectivity, and we will get the real-time result. When it comes to the real-time result, for an example, we are getting an input or a measure data from this particular, this is actually an example of a battery pack. Okay, so from the battery pack, we are getting a measured data, for an example, a HPPC data. It is transferring to this particular battery module, and it is getting processed, and we need to give it back to this particular real space itself. So first, one thing we need to think about is the simulation is supposed to be very fast enough. Okay, so solving complete model for such kind of a digital twin based applications is really difficult because it's a time consuming. We will not get a real time result as fast by using by if you are using a standalone or a default models. Okay, for that actually we need to build a behavior model. Here comes the usage of machine learning techniques or application of machine learning techniques in COMSOL multiphysics. So that technique we calling using for building such kind of a behavior model is calling it as surrogate modeling. So by using surrogate modeling, you can create very computationally less expensive model, which can be based on any kind of a physics-based simulations, which you have been doing using COMSOL multiphysics. So such kind of a features is available with COMSOL in terms of the machine learning, where instead of running for the complete model for this kind of a digital twin, you can build a surrogate model or a behavior model using surrogate modeling feature available. So basically, how surrogate modeling works is, so initially we will do a DOE based or design of experiment based study or a different set of simulations, a complete simulation. Then we will train those data using deep neural network technique. Then we will build the behavior model, or we call it as a surrogate model. So this is in the interface itself. You can see this is an example, okay, where the blue continuous lines are the complete full scale model simulation data, and these red dotted lines are the surrogate model which we have built by training those DOE design of experiments data using this deep neural network technique. Then you can see that actually we are getting a very good match or connections between both this data. Actually, this is an example of a battery. So such kind of behavior models you can build using COMSOL multiphysics for developing the digital twin for the real-time simulations. So as I have already told, the advantages of developing such kind of a behavior model using the surrogate techniques is something like instantaneous solutions, because this is just a behavior model. So when it's take the example of this particular figure itself, here you can see only 3 particular parameters are there and 1 output. Okay, so if you are changing this positive electrode thickness or negative electrode active material fraction, so any of these 3 parameters, if you're changing, based on that, this particular result will also get changed instantaneously. So that is, we call it as fast simulations, because if you're trying to do this kind of change in the legacy model or the full scale model, then it will take a lot of time. But as you have a behavior model that only 3 input and 1 particular output, and we trained a certain set of DOE data using deep neural technique, so it will work based on that behavior model. So it will predict very fastly. so that for building like a digital twin, we will get the result instantaneously, and the to and fro communications between the real space and as well as the virtual space will be fast enough. So that is about the one of the ML technique that available in COMSOL multiphysics for building digital twins. So for solving or doing all such kind of capabilities, whether physics-based simulation or the twin builder or the twin modeling, we offers a different product. So the base product is COMSOL multiphysics base product. So that is the base parent code where all the parent codes are been running. So it's consisting of a very basic capabilities as well, like all model builder, application builder, and model manager. All three are part of base package. And on top of that, there are physics-based simulation capabilities like all sort of linear simulations we can done it using COMSOL, a base package. But on top of that, if you want to do advanced simulations, for an example, if you want to do a multi-phase simulation, so that is not a part of base package. For that, you need to use the CFD module. Or if you want to do a non-Newtonian fluid flow simulations, then of course you need to use the polymer flow module. Similarly, when it comes to electromagnetics, if you want to do a rotating machinery or electric machinery simulations, you need to use AC/DC module. Then RF module is for HF and all those kind of a high frequency applications like antenna. Then wave optics and ray optics module, both are actually for the light simulations. As we all know, light can exhibits in both wave and ray nature. So when it comes to the wave optics, where the characteristics length of the device is nearly equal to the wavelength of the light, those cases we will use wave optics. That cases it will act as a wave. Then ray optics will be primarily for the optical systems where the characteristic length of the device is much more higher than the wavelength of the light. Such cases we will use ray optics. On top of that, as I have already told, we have a solutions for the plasma and as well as a semiconductor. So same way, we do have different add-on products for the different applications. Based on the requirement or based on our own research areas, we need to select the add-on products and you need to add it with the base package. So you can do the advanced simulations using COMSOL. And these kind of multi-purpose products are well suited with all the physics modules which are available. On top of that, there are interface products as well for connecting with some other third-party tools, especially for the live-link with MATLAB and Simulink, where you can build your own codes in MATLAB and you can transfer it into COMSOL for running the simulation. Such kind of connectivity, or coding connectivities or the customization things, you can done it using the live-link feature in MATLAB and Simulink. On top of that, we are providing live link feature for most of the design tools as well, like SolidWorks and CATIA, ProE. Okay, so now I'll just give an idea that why such kind of a live link features are available while doing simulations. Okay, because we do already have a capability to import all these designs directly into COMSOL. Okay, rather than designing, if you want to design it in any other 3D CAD tools, you can import it. On top of that, how live link feature differed from a simple importing. So the live link feature is actually like a bidirectional connectivity between COMSOL interface and as well as that particular third-party this 3D design tool. Okay, so this how the live link work it is. So I'll take an example of a topology optimization. So initially we designed a particular part in SolidWorks. Then we just import that part into COMSOL. We just do a topology optimization study. After the study, our topology or the design got changed. Okay, if you don't have a live link feature, then okay, anyway, this design got changed. We got the optimum design. Now we need to redesign. We need to redesign the base design which we have built in the SolidWorks based on the new one which we got after the topology optimization. So this actually we need to do it manually. Okay, we need to redesign, then we need to go for the manufacturing. So this is something like where SolidWorks is not connected with COMSOL. But if you have a live link feature, it is bidirectionally connecting each other. After the topology optimizations or any kind of design change, it will be automatically reflected into SolidWorks. Or if you are making any changes in the design, by chance, initially you designed, but you forgot to add certain part, Okay, then that case as well, if you have a leveling feature, you can add that part later in SolidWorks. It will be automatically reflected into console. So such kind of bidirectional communications will happen between those that particular design tool and the console interface through this particular leveling feature. So that's the reason we are offering leveling feature on top of this kind of a CAD import module or the CAD import feature. So that is all about the different offerings from the console and the capabilities. When it's more come to the topic of the renewable energy, okay, several areas where console worked is, first one will be the electric motors. Hello, someone unmuted. Hello. Okay. So
I request all the participants, please mute your mic.
So yeah, so when it comes to the simulation-driven R&D processes, primarily on the various areas in the renewable energy sectors, is first one will be the electric motors. So there will a lot of losses can happen to that particular device if you're not designing it in properly. Specifically these days, electric motors become a very, or research related to electric motors become very boom because of EV or hybrid vehicles. So that we can use the capability of COMSOL for designing various type of motors, then transformers, and also a different type of IGBTs for the semiconductor devices, also the power electronic device, then the battery, okay, then electrolyzers and hydrogen fuel cell, solar cell. I didn't include all those areas in the slide, but different areas where we can use the capability of simulation for developing a very sustainable products or the optimized products. So right now I'll just give a very brief ideas about the various aspects, but you can connect with your own research areas. Maybe I am only capable to cover very few things within a short period of time, but at the end, if you have any doubts, you can ask, or you can actually connect with how the things are being working, because few physics I'll cover it right now, and rest of the things you can connect and you can get back to us. So the first one I will talk about is the electric motors and generators, and also the the modeling of cable connectivities and the power electronics things. So basically, for all sort of this kind of low frequency simulations, the module which we usually use it is console AC/DC module. By using that, you can develop the various electric machineries like permanent magnet machines, or linear motors, or axial magnetic bearings. So all sort of different moving or the rotating machineries you can simulate it using console multiphysics. And also you can do various electromagnetic heating related simulations by coupling this particular AC/DC module with the heat transfer module. So through this particular coupling, actually you can understand the heat generation, and you can use several techniques to reduce that heat generation. That will actually lead to the optimum performance of that particular device. So this is a kind of case study where COMSOL team is worked with Volkswagen for developing an electric motor. So basically, initially they started with the designing of electric motors. Then they will just understand that it is actually kind of a repeating R&D processes. So they build an app as well based on the results what they got, or based on the model which they have built. So where they just done a multi-physics simulations to understand the electromagnetic behavior, and as well as the heat transfer thermal behavior of that particular electric motor for their EVs. And another applications, something related with the IGBT. Okay, so it is primarily, again, it is a kind of a multi-physics problem where they are completely looking into the electrothermal and as well as the thermal mechanical simulations. So basically, this particular semiconductor component is placing in a situation where a lot of heat can comes into picture, and also there will be a lot of vibrations and all. So they need to understand that this particular device is how it's be behaving under the various thermal condition and as well as the various mechanical conditions. So initially they just done a electrothermal analysis by coupling the electromagnetic solver with the and the heat transfer through solids module, that is the heat transfer module. Okay, once they got the temperature data, of course, because of the temperature raise and the external or the environmental temperatures, there will be some thermal stress formation and it will affect the mechanical performance. For that, they just done a thermomechanical simulations by coupling heat transfer physics with the structural mechanics. So they just done such kind of a, so it is actually a kind of a three physics problem where electromagnetics, heat transfer, and structural mechanics comes into the picture for developing such kind of a IGBT systems or the high power electrical systems. So that is about implementing electromagnetics related simulations for renewable energy. So the another area where a lot of researchers are these days happening is for the battery and as well as the hydrogen fuel cell. So these are two areas because of the boom in the EV, not only in India, all over the globe. There were a lot of people are actively working on the different aspects of fuel cell, electrolyzers, and batteries. And COMSOL offers dedicated interfaces for both the applications. When it comes to a battery design, we offers a module called a battery design module that is specifically for the battery design, and it consisting of various built-in interfaces for lithium-ion battery, redox battery, flow battery, normal lead acid battery, or you can build your own battery electrochemistry. All these electrochemistries which I have explained right now, they are built-inly available. But on top of, if you want to add your own electrochemistry, that is also possible. So on top of that, by using battery design module, we are able to simulate batteries in the various levels. So first one will be the heterogeneous model. So the heterogeneous model is something related with if you're doing a or if you want to understand even in the very micro scale level of an electrode itself or the particle in the electrode itself, such kind of a simulations you can done it using the heterogeneous model. It is actually very in-depth. Usually the battery manufacturers, they will do such kind of simulations to understand the performance of that particular electrode which they are been building. So it is more on a kind of a in-depth analysis. Next is the homogeneous model. So where instead of designing that each particle in that particular electrode, we take it as a homogeneous electrode. It will be a kind of a complete 3D structure. Then we will do the battery simulations or the cell level or a pack level simulation. Then next is a single particle model. So think about that. If you have a lot of electrodes, that too in a 3D model, and solving it a pack level simulation, it takes a lot of time. It is computationally very expensive. To avoid that, we just come up with an approach of a single particle model where electrodes will be considered as a single particle. So this kind of approaches will be really handy if you are doing a pack level simulation. Next is equivalent circuit model or a lumped model. So in this particular model, so for the first three, we are actually solving the entire electrochemistry in solver itself, in COMSOL itself. But when it comes to lumped models, instead of solving the entire electrochemistry in solver, actually we will import the experimental data like HPPC data from the battery designers to the solver, and we will do the rest of the simulations. So that is, again, it will be handy for doing a pack level simulation or the thermal. If the user or the researcher, if that person is not that much into the electrochemistry, he don't want to do anything on the electrochemistry, he's happy with the existing electrochemistry, but they want to do a thermal simulation for an example. In those cases, they can go with the lumped model approach. So these are the different type of or different approaches that available in COMSOL multiphysics for doing their battery simulations. Next is fuel cell and electrolyzer. For the fuel cells as well, we do have different interfaces for proton exchange fuel cell or the normal water electrolyzer. All those kind of interfaces are directly available in COMSOL itself for doing the fuel cell related simulations. And on top of that, you can add these fuel cell or electrolyzer interfaces with fluid flow and as well as the heat transfer module for enhancing the development of that particular fuel cell, or understanding the multi-physics or the flow behavior. All those such kind of problems you can handle by coupling those fuel cell interface with the fluid flow or the heat transfer interface. So this is just an example of building a PEMFSE fuel cell model in COMSOL, where actually you can build the electrochemistry and the fluid flow, and also you can couple the heat transfer, where it will becomes with a kind of a multi-physics simulation, where we couple different physics together for the optimum designing of this particular PVMFC fuel cells. So such kind of a problems actually you can solve. Then another will be when it comes to the battery. Primarily when it comes to the pack level, we usually interested on the thermal behavior to reduce the loss and all. So for doing such kind of a simulations, we do have dedicated battery packs interfaces, where actually you can do the cooling simulations of the different levels of battery packs. And another important feature in COMSOL is we do have an interface called a pipe flow interface. So if you consider this particular battery pack, okay, so it's consisting of various levels, and it is connected through the pipes, various pipe circuits for the cooling. Okay, so for this kind of an electrochemical cooling or the battery cooling simulations, actually what you can do is you can design the entire battery packs as 3D, and you can design this pipe circuits as 1D. Okay, and you can club together. Actually that kind of a feasibility is also available in COMSOL, where one physics you can design it in the lower dimension, and the another physics you can design it in or develop it in a higher dimensions. But and you can couple each other through this multi-physics coupling, and you can solve. So this kind of capabilities will actually aid to reduce the complexity of your problem. When I come back to this particular case, so instead of doing it as a 3D model, you can do it as a 1D model using this pipe flow interface. So it will be 1D we are designing, but we can provide the cross-sectional geometry and as well as the thickness of that particular cross-section. So through that, actually in the numerical technique part, it will be considered as a 3D only, but while designing and the meshing part, it will be considered as a 1D. So it is very handy for the user to when it comes to the meshing part, and also it reduces the computational time as well. So such kind of a feature is also available in COMSOL for such kind of applications like high-end battery cooling or very high-end pipe circuit simulations. So this is a case study where our team has worked with Toyota for building their hydrogen fuel cell for their cars, trucks, and all. So this is actually like a work which have we done with our team. So this is basically they were using this fuel cell module and as well as the fluid flow module for understanding the various fluid flow aspects of the fuel cell which they have building for their EV cars, trucks, and all. So till now, I was talking about the physics like electromagnetics or fluid flow or the fuel cell or battery. When we're developing any of such kind of a devices, the loss is primarily because of the heat transfer. So there will be some other losses as well. If two components are designing, if they are connected together. Hello. So if you connect it together and there is a relative motion, of course, there will be some friction, and because of the friction, heat generation will happen and losses will occur. Even when it comes to electromagnetics, because of the resistance, there will be some heat, and that will leads to the where you'd say the few losses. So understanding the heat loss or the thermal behavior of the system will be really important when we are designing any kind of a devices. That too, because with this actually we can reduce the losses and we can increase the performance of our particular device. So for that, the thermal management study is really important. So if we take the two physics which I have already explained, so the basic three modes of heat transfer which COMSOL can handle it is all like conduction, convection, and radiation. All three we can solve it as a standalone one. For an example, if you want to solve conduction alone, that is possible. Convection alone, that is possible. Or radiation alone, that is possible. Or if you want to solve the combination of two or all three, that is also possible. If you take an example of conjugate heat transfer, where it is a kind of phenomenon of conduction plus convection, there will be heat transfer in solid medium and as well as the liquid medium. So such kind of a problems also we can solve it. So some other features when it comes to the heat transfer modeling using COMSOL it is. So basically, by using COMSOL, you can directly accommodate the various type of thermal conductivity like anisotropic, linear, non-linear, all those kind of material properties we can directly model in COMSOL multiphysics, where you don't want to write any kind of additional code. And also there are features like a thermal contact, because if two parts are getting contact with each other, there are one method is directly actually we can design the two component in a single part and you can solve the problem, where conduction will be completely like there will be a direct conduction between the two parts. It is more idealistic in nature. Actually we required, if it is a assembly kind of a problem, we required a kind of a thermal contact boundary where actually you can specify the source and the sink so that the heat transfer will be proper, and if there is any loss, that loss will also get inquired. If it is a designing it as a single part, there will be no loss. So that is what I told, it is very idealistic. When it comes to the real scenario, that loss will happen. Without going with such kind of an approach, if you are designing, definitely it will be an inappropriate design and the losses will be more. So that you can use the thermal contact feature that is available in COMSOL conduction module for providing the conductions or the boundary condition to heat transfer from one part to another, where it is getting touched in a partial way for an assembly kind of a problems. Next is the convection. Both free and forced convections we can solve it using COMSOL, where when it comes to the flow part, you can accommodate both laminar and turbulent flow, and also different type of turbulent models can also used in for this kind of a convective problems, and you can couple this conduction and convection for conjugate heat transfer problems. And another is radiation, where your temperature is too high, where the heat is dissipating in terms of radiations. This will becomes for this kind of semiconductor applications, radiations are really important. So where you can simulate surface to ambient radiation, or radiation in participating media, or surface to surface radiation, all sort of different radiation mechanisms we can directly solve it using COMSOL multiphysics. So these are the different type of heat transfer mechanisms we can solve it using COMSOL. So solving any kind of a heat transfer problem, the key important feature is the heat source. So as I have already told, while we are designing a particular problem, the heat source is not idealistic. If you are designing a motor, for an example, where if you want to design the motor efficiently, you need to do a electromagnetic simulation. Because of the electromagnetics, there will be heat generation. That is electromagnetic heat generation. So basically that is the heat source. So in all the CAE tools, there are different methods. So the first method in almost all the CAE processes, user-defined expressions. So here in this particular first approach, user-defined approach, how we solve the problem is, we solve the problem in such a way that we'll input the heat value. For an example, 1000 watts or something. That particular value we are directly inputting, or we write it as an equation itself. So that is a one method. So that is a one first idealistic approach. Another will be solving one problem, taking the heat map value from that, then add it to the heat transfer and solve. So this is the kind of approach most of the tools basically use, where they'll solve first physics, then they'll take the temperature value or the heat value, then they'll give it to the heat transfer solver, then they'll solve the heat transfer problem. It is also idealistic in nature, where there will be no bidirectionality, where it is not considering the aspects of interchanging the data. So the best approach for solving such kind of a heat transfer problem to understand the heat generation because of the losses is the multi-physics coupling, where we will couple different physics together in a single interface and we will solve the problem. So such kind of a multi-physics coupling is what COMSOL do. Actually, the first two methods also you can do, but the recommended way of doing such kind of a heat transfer problem or getting the heat source is from the multi-physics coupling, where initially we will solve the dominating physics. Just below that, we will start solving the heat transfer as well together simultaneously. So there will be bidirectional data transfer and it will give a very realistic result, which will be how it will be behaving in the real world scenario. The different multi-physics coupling that available is, first one will be the microwave heating. That is a coupling between RF module, that is the radio frequency module, where understanding the heat generations because of the microwaves. So the one particular example or the figure you can see in this is actually like a chip which is inserted inside a human skull. Okay, so because of the continuous operationality of the chip, how much amount of heat is getting generated and how it has been transferred to a human body. So such kind of a simulations we can do. So where it is coupling with RF with the micro heat transfer. Next is Joule heating. So this is an example of a bus bar where there will be electric current, and there will be, because of the electric resistance, there will be some heat generation. So that is we are solving with the Joule heating. Next is the inductive heating. So all these three, microwave, Joule and inductive heating, falls under the electromagnetic heating part. Next one will be the thermoelectric generator or the thermoelectric effects, where like Z-back effect and all those kind of a problems you can directly solve it using COMSOL. Next is the conjugate heat transfer, where we are coupling CFD with heat transfer or the fluid flow module with heat transfer. So that is also again a key important feature. Next is thermal expansion. As you all know, because of the temperature, there will be some expansions, or the rise in temperature, there will be some expansions. So that particular problems will connect with the heat transfer with the structural mechanics module. So that you can do it. Next is electrochemical heating. It's like a heating because of the electrochemical reactions, like battery or fuel cell, that kind of a things you can do. Next is the heat and moisture. So all the multi-physics capabilities which I have listed in this particular slide, COMSOL have a dedicated interface for solving such kind of a problem. So for any of such kind of a problems, you don't want to build the multi-physics interface. You need to select the first two interface. Automatically, the respective multi-physics will be automatically get developed in the model builder. That I will show you later. So that is about the heat transfer part, and this is a kind of case study where our team worked with the Bosch, where they are been developing a DC link capacitor. So basically, in this particular problem, these DC link capacitors are closely packed, so that they already aware that there will be a significant heat generation. So they need to predict the heat generation, how much amount of heat is generating, and what type of cooling mechanisms we need to use. So even before they are starting the experiments or building the product, earlier stage itself, they have done the simulation using COMSOL multi-physics. Then they just understood the hotspots in that particular device, and they used a proper cooling mechanisms to reduce the heat, and they just come up with the optimum performance of that particular DC link capacitor circuit. And the next, sorry. Okay, so that is about the one case study from the heat transfer perspective. Okay, now I'll just quickly open the tool and I'll just explain. Okay, so this is how the COMSOL interface looks like. Okay, so this is called the ribbon window or the ribbon tab, where all the functionalities for building a model will be available over here.
Sir, is this open source tool or?
Hello?
Is it open source tool, sir?
No. It's a licensed tool.
Okay, sir. Thank you.
So this is how the COMSOL multiphysics interface looks like. So this is the ribbon tab where all the functionalities for building a model will be available over here. And this will be the model builder window, where this is the place where we will give all the inputs one by one for requirement of a building a model. So that is the model builder. The next is the settings window. If you are selecting a node from this model builder, the corresponding inputs we will give it in the settings window. This is the graphics window where user will get the visual, user can see the changes or see the model, the visual things we can actually do it over here in the graphics window. This is the information window. We will get the informations regarding the model which you have been building. If you're getting an error or warning or progress and the log files during the simulations, we will get it from here. So that is how the overview, like this is how the COMSOL interface looks like. Now, this is actually a problem of this is actually a problem of a solar cell or a solar plates, okay, which is actually placed in a specific place, and where wind is the wind is flowing with a specific velocity, and it is actually to understand the structural or the fluid structural interactions. So the two physics will comes into the picture is solid mechanics and the turbulent flow. Before that, I'll just talk about the hierarchy or the process of building a model in COMSOL. So as we all know, all the CAE process we usually starts with the geometry creation. For building the geometry, COMSOL have a lot of tools that directly available for building the geometry. Okay, like and also all the operations like extrusion, revolve, all those kind of operations are also directly available, so that by using those operations you can build your design in COMSOL interface itself, or else you can actually add or you can import the design from the third-party tool as well. Once after that, you need to select the material. So this case, actually, we build the model in COMSOL itself, but it is actually for a demo purpose. I have imported from the external files. Okay. So next is we need to add the materials. When it comes to the material library, COMSOL have a very vast material library consisting of material more than 50k, 15k, 15k materials are available in COMSOL material library, and it is listed based on the applications. AC/DC, if you're solving the battery, that battery related. Then if you're solving some semiconductor problems, that semiconductor related materials, all those materials are available, or the generic materials like air, water, those things will be available in the built-in drop down list. So from that, actually you can select the necessary materials which is required for your simulation, that you can directly select it over here. You can just double click on that particular material. For an example, I just select the high strength alloy steel. If I double click, it will actually add it into our particular model builder. Then you can select okay, then you can select the domain where you need to assign that particular material. So for an example, if you take air, this entire domain is considering it as air. Okay, that is the atmosphere. Then there are domains where structural steel is provided. There are regions where aluminum domain, or there are places where glass, that is actually the solar cell. We consider solar cell like glass is actually the property we give to solar cell. The accurate properties also you can give. So such a way that you can add the necessary materials required for the simulations, and you can append it to the or you can add that corresponding domains. So if there is any part having a high strength steel, that actually you can select it accordingly to that material property will be assigned to that particular part. So that is a process of adding materials for the simulation. Once after that, we can actually provide the informations regarding the bound physics. where the various type of boundary conditions you can give. So primarily, while solving any kind of a problem, there will be few default nodes. That is actually the D will be there, like fluid properties. So two ways are there. Either those required fluid properties will be taken by the materials which we have provided over here. For an example, in this particular part, the two domains are assigned 1 and 2. That 1 and 2, it is actually assigned to air. So what will happen is, for this particular fluid properties, they will take this properties from this particular air material. So that is how this particular feature work. But on top of that, sorry, on top of that, if you want to add your own material, you can use the user defined function, and you can actually give the material property over here. So those options also available. Then next is initial value. For solving any problem, we require actually the initial parameters that you can give. Next is wall, where all of the wall region. Next is the periodic boundary condition. So why we give periodic condition is actually like these things are open to the it is actually repeating. Okay, we are doing a kind of a symmetric, and it will be like periodically like placed with a different n number of array like rows and columns in the array. Such kind of a problems, actually you can use periodic boundary conditions, where what will happen is flow will comes and leave. Then actually if there is a this kind of particular solar cell is placed over here, actually the inlet condition for that particular solar cell is the outlet condition of this particular phase. So such kind of a continuity it will be given for by using this kind of a periodic flow boundary conditions. The next is symmetry, because it will like symmetrically it will place, there will be like repetitions is there. Next is open boundary. Open boundary is a feature where it is completely exposed to the atmosphere, a huge amount of air domain. So that is we collectively calling through this kind of open boundary. So then one simple equation I have added for considering the pressure difference between this inlet and the outlet of this particular periodic flow. So that is actually I'm giving it as an equation. So why I have did it is this is how actually we can add our own equations using this kind of equation based modeling. While talking about the various capabilities of COMSOL, I hope you remember that I already explained about that we can add our own equations into simulation. So this is how actually we can add. So I am created a term called pressure difference. So that is actually the pressure difference between these two surfaces in the open boundary as a function of velocity at the top surface, and as well as the average velocity which is calculated by the solver itself. So such a way where we can create our own parameters and we can add it as a boundary condition or a domain condition for the simulation. So for that, actually, we don't require any codes. It is actually possible through the GUI process. So just to demonstrate that, I have added this particular pressure difference. So that is about providing the boundary conditions for the turbulent flow. So here there will be questions that the users who already used CFD tools, that they will have a question that there is no inlet and outlet. Actually, this periodic flow conditions will taken care of the inlet and outlet, so that you don't want to use any additional inlets and outlets for this kind of a CFD problems where flow is periodically repeating in nature. So next is the structural mechanics. So here you can see for the structural mechanics, we have assigned all the domains other than that particular air region. So when it comes to this particular elastic material, so here as well material properties are there. So they respectively taken from that particular material properties which we have assigned over here. They will take it from that. So then we need to give the boundary conditions like fixed boundary. So on top of that, the various boundary conditions available is something like boundary load. That is that if you have a load on the specific boundary that you can give, then fixed constraint is for the fixed support. And if you have a prescribed displacement, that if a boundary that is actually moving in a specific direction, in a specific length, so or the distance, those things you can provide it over here. And also the roller boundary condition, if there is a situations where there is a movement in the in plane, that actually you can do it. and also the thin layer. So such various boundary conditions are available for structural mechanics. Similarly, different boundary conditions are available for fluid flow as well. And for all the physics, it will be available. So which boundary conditions, how you need to set up the problem, that either you can go through the theory manual related to that particular physics, and as well as there are a lot of example data that available in COMSOL itself that I will show you at the end of the demo. Okay, so once we provided the necessary information for these two physics, next is we
Excuse
need
me,
to.
sir.
Yes.
Sorry, sir. I am Dr. Ravi. If you
Yeah,
don't
please.
mind, another resource person also waiting, sir. If you don't mind, please try to.
Yeah, till 8 o'clock. I
Yes.
think 6:30 to 8, right?
8 till 8 for
Yes, sir. Yes, sir.
Yeah.
Yes,
Yeah,
sir.
sure, sure. I'll wind up by
Fine, sir.
8 o'clock. No problem.
Fine, sir. Fine, sir. Thank you.
Okay. So once after we provided the informations for this standalone physics, as I have already told, so we do have a dedicated built-in multi-physics interfaces that will give the connectivity between this kind of two physics. So fluid structure interactions, it connect the turbulent flow and as well as the solid mechanics. So COMSOL, it's intelligent enough to take the necessary data from here for solving this kind of a multi-physics problem where user don't want to think much about the multi-physics part. So it will be automatically taken care of by the solver itself. So that is what I was explained during the initial phase itself, that COMSOL have a various multi-physics interfaces that available by default or as a built-in feature. So it will be handy for the users to do a multi-physics simulation. Then we can mesh the geometry. When it comes to the meshing part, COMSOL offers two type of meshing. First one will be the user controlled mesh, or there is an automated process that you can create the mesh using physics controlled option as well. That is an automated process where software itself will create the mesh based on the physics which you have been solving. It will be okay for an intermediate level problem. When it comes to complex problems like this, we need to go with the user controlled mesh option. Then you can solve the problem. So different type of studies are available. It can be transient or stationary for the CFD problems. When it comes to the structural mechanics problems, it can be eigenvalue or frequency based or random vibration. Different type of studies are available in COMSOL based on different physics, so that we need to explore it through the user manuals. So once after that, once you run the simulations, you will get the predefined plots from COMSOL. So for an example, this is actually the plot of the displacement plus streamline, because as it is a multi-physics problem, in a single plot, we can understand the behavior of two physics. First one is a displacement and another is a streamline. So even when it comes to the streamline, you can see the velocity is higher at the top region, so that the maximum displacement or the deformation is happening in the top region. So that's way actually you can conclude, and you will get the different predefined plots from COMSOL directly. So this is actually like once you run the simulation, these kind of a plots you will get it by default. On top of that, if you want to add your own plots, so there is it's also possible. You can come to result and you can create 3D, 2D, and as well as a 1D plot, that is graphs. Okay, and that is how you can add your own plot. Also, if you want to add your own parameters, for an example, here it is actually like pressure. So instead of getting it as a what you'd say dimensional value, suppose if you want to write your own expression, for an example, I want to know a parameter like p minus 100. So that is the expression which I want to get as a result. So that actually you can give it, and here you can see initially it was 60. So that is a p minus 100 is minus 40. So that way actually you can write your own expression to get the result. So it will be really handy that you don't want to use any third-party simulation or any third-party post-processing tools to get the result. So all those features will be directly available in COMSOL for getting the result. So this will be really useful, because whenever we are publishing papers in some reputed journals, they usually accept non-dimensional data. or non-dimensional graphs or plots. So such cases, some other tools don't have this expression feature where you want to adopt or you want to align with some other third-party post-processing tools. But in COMSOL, you can directly write your expression which is required. Then you can get those results. But the one thing you need to keep in mind is what all are the parameters you are writing over here. That parameter is supposed to be solved as well. For an example, you are not solving temperature, but you are trying to give a temperature parameter over here, then you will not get those results. So that you need to keep in mind. And which all are the parameters are solved in this particular case, how you can check it is, you can come to this expression tab and you can create enable this expression view, and you can come to the particular physics, and here you can see which all are the parameters are getting solved. Okay, for an example, velocity, different velocity and pressure related parameters are getting solved. When it comes to turbulence, what all are the parameters are solved. Okay, all those informations you will get it, and based on this you can create some derived expressions and you can solve it. Or you need to solve that particular expression as a parameter or something, then also you can actually get those results through expressions. As a user defined expressions, you can get those results. So this is how, or this is actually the model building process in COMSOL multiphysics as an example of a solar cell. Now quickly I'll just give an idea about the COMSOL app as well. So this is actually an example of a heat exchanger. Okay, cross flow heat exchanger. It's consisting of fluid flow and heat transfer. So here you can see there are two fluid flow interfaces are available. One is for the inner pipe, and another is for the outer pipe. Okay, and there is a interface between these two phases. So this is how the problem statement. I'm not talking completely about the model building process because that I have already explained, but I'll show you the multiphysics feature. So here you can see we are coupling two fluid flow with one heat transfer. So two non-isothermal flow multiphysics interface is required. Actually, that will be automatically created by COMSOL. So non-isothermal flow, as I have already told, it is coupling the CFD and the heat transfer module. So here you can see the first non-isothermal flow, it will consider this particular SPF and the heat transfer. And the second non-isothermal flow, it will consider the second SPF2, that is this particular fluid flow and this common heat transfer module or the interface. So that's how this problem solved. And I'll show you how the apps looks like. Okay, so this is an app which we have built based on this particular feature. Okay, here you can see when I click on the test application. So here we don't require, or we don't want to give a lot of informations regarding the conventional model building process. Instead of that, only few informations we need to give. Just a minute, it is actually getting load. Okay, so here you can see there are parameters in terms of the tube, that is a length, inner dia, outer dia. Okay, all those inputs you can give. On top of that, you can change the flow parameters of the inner tube and the outer flow tube. So we are only changing few parameters and we are getting few other results. So here we are not doing any kind of a meshing. Here we are not doing any kind of a multiphysics coupling. All those things will be taken automatically during the model building process. So as a user, if you are using this particular app, you only need to change these parameters and you can click on compute. It will compute the problem and you will get the result. So it's computational, like it takes some time to run the simulations, but you don't want to solve the entire model. You only want to solve the few inputs and you will get the few outputs. So this is how the apps looks. Okay, by different way, actually you can build the app for different physics. That will be again depend upon your requirement. And on top of that, the good part of app is once you build the app, so for that actually as I've already told, we need to do a simulation in the model builder. Then we will come to the application builder and we build this particular app. Once you compiled this app, you can create, once you created this app, you can directly run this app to a system where console is not installed. That's what it is saying. It is, if you want to run an app, console license is not required. For building an app, yes, it is required. Once it is built, you can share these apps to any person, where if they want to change a few parameters and to understand how it is behaving with a few 1 or 2 result, they can even run without a console license. So it will be really useful that if you're transferring certain data to another customer, so instead of preparing a presentation and send it to them, you can build the app and you can send to them and ask them to change the data and see the result in console software itself without a license. So it is really handy on that point. Another point is, if a development team consisting of 10 or 20 people, but only 1 or 2 CA engineers are there, rest all CAD engineers. So they want to do, or they want to build or try for a different designs, but instantaneously they want to know the result. So such cases, the CA engineers can build the app and transfer to the CAD engineers, where CAD engineers might not aware about the meshing. So it is not easy for them to build the base model. So they can change the parameters in the app and they can understand how the flow or any physics is been behaving for that particular design, and they can come up with the optimum designs. So that is how the app work. So that is about the very basic idea about the model building process, and that is how the apps looks like. So with this, actually, I'm just going to conclude my presentation. So where by using COMSOL multiphysics, you can do the realistic multiphysics simulations of various devices or products using COMSOL multiphysics interface for the different applications with a very high level of accuracy. So as I've already demonstrated, you can connect n number of physics together to build a multiphysics scenario. Then you can do the multiphysics simulations and you can design your product in a well-optimized way. So with this, I'm winding up my presentations and the demo part. It's open to the questionnaires. You can, if you have any doubts, please feel free to ask the questions. Or if you have any more questions in related with the research activity which you are doing, or you want to integrate COMSOL into your research, then you please feel free to write it to our support portal through the mail address which is shown over here. We are happy to have a further discussions on that. So based on the today's presentations and the demo, if you have any doubts, please feel free to ask.
Sir, I think some students have a query whether COMSOL is a paid or a free software, open access. And
No.
chat window also few questions are there.
Okay, I'll open the chat 1 minute.
Yeah.
Yeah, the first question, like whether if it is an open source or not, of course, it's not an open source software. It is a paid license level software. You need to purchase the license, and by using that license, you can run the simulation. So again, license is also depend upon the which physics which you have been solving. The base license is required for all. On top of that, you can buy the add-on product licenses and you can solve the problem.
That's happy.
Yeah, chat, actually, I'm not able to see much question.
Sir, I think there was a question on whether equation-based modeling is possible for corrosion in COMSOL.
Yes, it is possible. You can build the so the question is, I hope it is from the electrochemistry equations or something. It is possible. Equation-based modeling is possible for all physics. Or if you want to build your own physics, that is also possible. For corrosions, if your question is something related to building an electrochemistry, that is possible.
Any other questions? Participants are free to ask. Please unmute and ask.
Sir, this is Zakir Hussain. I have a question.
Yeah, please.
Sir, all the multi-physics models, I mean, in the beginning, you have mentioned that 3 physics that need to be identified before coupling and do some coupling process in this 3 physics itself. I mean, 3 multi-physics itself. Is there any constraint on that particular 3 number?
No. 3, I just told, take it as an example only. You can add n number of multiphysics. So based on your own product. So for an example, I'll take that particular example itself. you want to perform the heat transfer and the acoustic behavior of the motor as a multiphysics problem. So you can couple electromagnetics, heat transfer, then CFD, then structural mechanics for the vibration, then acoustics for the acoustic problem. So these 5 physics, in that case, you can add. So there is no limitation. You can add based on your own physics.
Okay, I have one more question. That is, all the physics that related to the closed environment, this tool is good, or open environment like ozone simulation and other things? I mean, can I use this physics for that? I mean, multi-physics for simulating ozone impact?
Ozone impact in the sense, so it depends upon, for an example, if there is because of some light sources, there is some ozone depletion. That is actually a kind of a chemical reaction. So if you want to model that reaction, actually you can build that reaction in COMSOL. But it is not like some, there are some atmospheric modeling tools. So it is not like that. This is a physics-based tool where if you want to do any kind of because in ozone, it's primarily on the oxygen content, and because of the presence of UV rays, there are some chemical reactions are happening. How the reaction is happening in a specific block, it could not be an infinite domain. It's supposed to be in a finite domain that you can actually solve.
Okay, thank you, sir.
Yeah.
So good evening. This is Srinivasan.
Yeah.
Sir, can you please little elaborate on the free feature, like without software, without buying the license, you can use some COMSOL, no? Can you tell me in the what extent we can use it? What way you can use this? Make use of this?
Actually, without license, what I have told is an app. Okay. So, but building an app, it's actually required a license.
Okay. Okay.
So, for an example, you are using a kind of, you are building an app and you want to give it to a team. You only have a license in your machine. But so in that case, actually, you can build an app in your machine and you can give it to your fellow colleagues or the research students. So they can actually open the app and change the input parameters. For an example, that particular pipe example, if you take, they can simply change this particular variables, and they can get the corresponding these two results. When it take this particular example, they will only get these two results. They can't explore more the CAE parts. It's only they can work based on this app. Running this app does not require a license, but building this app required a license. A CAE license is required.
For both the ends, like both sender and the receiver?
No. App is built by a sender only. The sending person. If I am building an app, I require the license.
Okay. The other person without the app, he can just run the data what is sent by the sender.
Yes.
Okay. Okay. Thank you. Thank you.
Yeah. There is one question that, do you provide the demo session? You can directly connect with us, Selva Prashant P. So you please directly write to us, because demos, it's again depend upon, in COMSOL, we do have dedicated tutorials that are available. If you have a solver, you can directly get it from that. So those discussions, actually, we can have it further. You can directly write a mail to us by mentioning that you have attended this particular event.